Welcome to this presentation on the Virtual Buildings Information System, which provides a means of connecting disparate data to achieve your outcomes. The volume of building data and documentation is always growing. Most already face the challenges of data accuracy and access in a timely manner. With the increased adoption of connected devices and cloud-based applications, the level of data gathering is growing exponentially, together with the issue of data accuracy, access and volume. With such trends, those who can analyse and operationalise the data will reap the benefits. To do this, the data needs to be structured and easily accessible. The Virtual Buildings Information System is a government-funded project to create an industry syntax to permit generic and reliable links to be created between applications and data repositories, and a standard convention for asset record tagging, which creates a logical and consistent data hierarchy. Cloud-based facilities management software is empowering facilities managers. There is a general trend towards cloud-based applications or software as a service. Facilities management teams now have easy access to state-of-the-art tools that provide access flexibility. IT obstacles such as accessing the latest versions and features are removed. They provide improved ability to focus on the real facilities management decisions. Software as a service products can be flexible and dynamic tools that evolve and grow with the organisation's size and need. However, issues remain. Interconnectivity of the different packages, standardising data referencing within the databases, and ability to compare new and old databases. But first, some background on the shift to predictive maintenance and the requirement to undertake life cycle analysis. This is a typical asset life curve that shows the resistance to failure dropping over time. There are three key milestones on the curve. The point at which failure begins to occur, typically at the end of warranty period. The potential failure point, where the asset starts to deteriorate. It requires condition-based maintenance and the chance of failure increases over time. The functional failure point is a time where failure becomes very likely. So the three stages can be broken into early, mid and end of life. But there are two other critical points on the curve. These are, where are you now? And where is the functional failure point? That knowledge provides you with the remaining asset life. Remember that the end of life is too late. You need to know when you have to replace the asset before it fails and compromises the facility operation. So what are we looking for? We want to predict replacement before the asset fails, and this will require maintenance and breakdown to be recorded against the asset record. Remember that ISO 55000 defines asset management as the coordinated activity of an organisation to realise value from assets. To achieve this to best effect, you will be required to undertake predictive maintenance and capital replacement planning. So we're looking to identify the abnormalities, such as energy use, breakdown, deteriorating condition, or frequent replacement. And to do this, and compare your failing asset to others that are the same or similar, you will require a consistent way to categorise your assets. I'll show you a practical example later in the presentation. So let's look at the information stores. This is not all of them, but the major ones. We have documentation, FM systems for planned and reactive maintenance and life cycle, BIM, 2D drawings such as electrical schematics will always have a place, building monitoring control systems, safety and OH&S systems, finance for capital expenditure and planning, the asset database, service systems, and let's not forget the Internet of Things in the cloud raining data into databases. The nature of software as a service is that each system is specialised and very good at what it does, and software as a service systems are inherently designed to be interfaced to other specialist systems. So what we want to do is link these stores. In the FM operational world, the key is the service system. It is this system that is recording both routine and breakdown calls and recording this information against the asset records. So what we want to do is use the asset record as a master reference point and then link it to the other stores to retrieve information, either for analysis or as an entry point into another system. And this is where VBIS comes in. VBIS is a government-sponsored project to develop an industry standard for asset categorisation to suit FM. The project objectives are to provide a multi-level categorisation structure with asset details suitable for planning and operation, provide a simple means to obtain standardised asset classification, facilitate data comparison and retrieval across disparate databases and unstructured asset data, an open standard, freely available and managed by a not-for-profit and the industry as a whole. Easy to deploy for new projects from inception and into existing FM systems. System agnostic, it's intended to work with your existing applications and new off-the-shelf, and to resolve the issue of disparate and unstructured asset data. There are two aspects to VBIS, one being the asset tagging and the other a language to permit application linking. So first turning to tagging. The VBIS tagging has wide application. It can be considered a Rosetta Stone. It provides a consistent search basis across asset databases. It can standardise asset structure. It can provide cross-reference and coexist with Uniclass, Omniclass and other defined standards such as hashtag. It facilitates linking of BIM model objects into O&M document repositories. It facilitates linking of database records into O&M document repositories. And it is compliant with ISO standards, ISO 12006 and 22274, the same standards met by Uniclass and Omniclass. The frequently asked question is why not follow standards such as Uniclass? The answer is that whilst the systems are suitable for construction, they do not provide the granularity required to analyse asset databases or link to specific types of equipment information. They present issues with both gaps in categorisation and shallow structure. Presented here is an example using pumps. VBIS uses 4 levels of categorisation to derive a tag. You will note, when compared to both Uniclass and Omniclass, in this case, they are providing in effect a 2-level structure. Further, note the gaps in the structure, which present 2 issues, the obvious being the missing categories, but more significant is the lack of partial categorisation available. This is particularly important as assets are progressively surveyed. In a first pass, the person undertaking the survey may not be able to determine all of the detail, in which case a tagging can be partially completed, for example, the MEPU tag. If all they can determine at the early stage is that it is a mechanical pump, they can record this partial tag. A specialist can return later to determine a more exact categorisation. So we'll continue with some discussion on how the code is constructed and how it suits searching. The code is prefixed with a discipline, in this example mechanical, and then equipment code for the pump, PU. Then the code is taken down 2 additional levels to make it more specific. A centrifugal end suction pump would be an MEPU CES, and if it was a long couple pump, it would have the LC added to the end. If the same types of pumps exist in hydraulics, then only the prefix has changed to HY. So when we come to search, we can do a number of things. We can find discipline-specific instances of the different types of pumps by wildcarding only the end of the code and not the start. But if we wildcard the start of the code, then we can find all instances of a particular type of pump, regardless of what service or discipline it is. Or if we wildcard both ends, we could find all centrifugal pumps regardless of discipline or type. Now we move to a practical example. Remember the life cycle curve and a cluster of failures? What does this look like when reviewing asset records in a service database? This is an example of an analysis of service calls against fan coil units on a client site. The time period is from July 2017 to January 2020. Note that there's an increase in calls as time goes on. What we want to do is pick one of these peaks, determine the asset category, and then search other databases. Perhaps the equipment is reaching end of life and requires replacement, By searching the other databases for the same type of equipment, we can look for patterns. Is this a common type of equipment? Is this particular model of unit an issue? Is it related to manufacturer or operating environment? All these questions can be addressed if we have a means of finding like types of equipment, both within the same facility asset database, across a portfolio, or across multiple provider databases. We can focus on one of the peaks and one of the service calls in that peak. From there we can call up an asset record. So far this is standard process. The asset record has a VBIS code, and in turn this provides a generic equipment categorization, even though the description field does not correctly describe the asset. Now we have a code, we can progress to search the database for assets for the same code and start to resolve questions as to causes of the rising incidence of breakdown calls. Before proceeding to the next demonstration, a brief word on the VBIS syntax. Rather than a hard-coded link between applications, the approach is to provide a search and display request. It uses standard URL query syntax, which is the same browser field that you type a website name or enter a Google search query. This has the advantage that it is portable, and the target application can be replaced and upgraded, yet it will still provide results if it recognises the request instruction. It has the further advantage that all version control of documents is handled by the target application. Provided here is an example of a URL instruction with the breakdown of its meaning. The result in this case will display a drawing. The demonstration will provide numerous examples. This is presented so that you can understand the mechanism being used. The request can be as open or as specific as required. You will see in the demonstration that in some cases the request provides a list of documents to the users, in others it provides a specific document. In our final example, we will demonstrate the VBIS syntax showing how a 3D virtual tour is linked to an online O&M manual. The key concepts being shown are integration of cloud-based tools, use of a simple linking language that does not use hard-coded links, VBIS operating as a search and display syntax. The demonstration shows integration of Matterport, a 360-degree photographic portal, Wise Working, a cloud-based O&M manual, and VBIS syntax. You will see the user navigating from within the 3D assembled image to a cloud-based O&M manual, then to an asset record, and back into the 3D model to view a specific asset. Thank you for watching this presentation. For more information about VBiz and our industry partners, please visit our website vbiz.com.au.